Okay, this will be some example problems from 6.1, graph of sine and cosine functions. I want to talk about a couple things in the text. These, anytime you bump into one of these blue boxes, it's going to be pretty important. So if all you knew that were the blue boxes, it would be pretty useful. The orange that say how to, they are oftentimes a summary of those blue boxes. Not all of them, but a lot of them. And I'm going to show you, I've teased this out here. So page 508 has a blue box, page 509 blue box, 510 blue box, then 511 blue box. Well, 512 says given a sinusoidal function of the form, that's our form with all of our changes, identify the midline, amplitude, period, and phase shift. You need to define those words in your notes. And here it sums it all up for you. Amplitude, period, phase shift, midline. Look at these previous ones. Period, amplitude, midline. So often the orange box is the how-to that summarizes the blue box things. Also with regards to our book, if you go to the end of every chapter, so we're in chapter 6 now, I'm going to just go to chapter 7 and back up a couple pages. You get the chapter test, the practice test, and then some review problems. Right before that is the summary of the chapter. The key concepts, this is everything you need to know in 6.1, and it talks about each one of the examples explained out basically. In this chapter, all of these key terms are going to be pretty important to us. Alright, let's look at a couple of example problems. Okay, 6.1, I'm looking at this 6 through 17. It says, for the following exercise, graph two full periods of each function, state the amplitude, period, and midline. State the maximum, minimum y values and corresponding x values on one period for x greater than 0. Round answers to 2 decimal places if necessary. You can graph all of these using Desmos, alright? I will expect you to be able to do by hand y changes. If it's an x change, I'll allow you to use Desmos to do it. What do I mean? Well, looking at number 6, this 2 is a y change. It's not inside with the x. This 2/3 is a y change. This -3 is a y change. Where are some x changes? We don't see any until number 11. Number 11, you see this 2 multiplier is an inside x change. Number 12 has both a y change and an x change. Looking down here at number 15, here's a good example of everything. The 3 and the 5 are y changes. The 8 and the 4 are x changes. They're inside. Remember, inside inverse. So, by hand, I'm going to expect you to do one like number 6 or number 9 or number 10. You'll be able to use Desmos to do 15 through 7. Right. For example, I'm going to do one like number 6. Number 6 says 2 f of x equal 2 sine of x. I'm going to do y equals 1/2 sine x. Okay, so now we're going to look at graphing the function y equals 1/2 sine of x. In order to do that, we'll start by graphing the parent function for that, y equals sine of x. Here you see the table that we filled in yesterday. We have 0, 90, 180, 270, 360 for all of our, and also in radians. Pi halves is 90 degrees, pi is 180 degrees, so forth. We have all of our 6 main functions, sine, cosine, tangent, cotangent, cosecant, secant. This is just a cleaner version of the table we filled in yesterday. Okay, so I'm going to graph y equals sine x. Well, I know that it oscillates, bounces back and forth between 1 and -1. Here we see the values here. So the problem asks for 2 periods. Pi has sine has a period of 2 pi, so 2 periods would send us out to 4 pi. And here you can see I've just counted by halves. 1 pi half, 2 pi halves would be pi, 3 pi halves, 4 pi halves would be 2 pi. 5 pi halves, 6 pi halves would be 3 pi. 7 pi halves, 8 pi halves would be 4 pi. I'm just counting by pi halves all the way out. It's like counting by 90 degrees. 90, 180, 270, 360. So looking at my y-axis, why did I choose 1 and -1 where I did? Well, I know that's the standard range for the parent function, y equals sine x, and I know I'm multiplying by 1/2, so it's going to be compressed. It's going to be less than this 1 and -1. If my multiplier here were 3, I would need to go out to 3. If my multiplier here were 5, I would need to go out to 5. So make your picture fit what your graph is going to look like. I know that mine is going to be compressed from these from this 1 and -1. That's why I spread it out like I did in my range. So at 0, sine is at 0. So at 0, we're at 0. At 90 degrees, we're at 1. 90 degrees is pi halves, so 90 degrees, we're at 1. At 180, we're back at 0. 180 is pi, we're back here at 0. At 270, we're at -1. At 270, that's 3 pi over 2, we're at -1. And at 360, we're back at 0. This is one full period. After this, it's just going to repeat. So 0 is 360. The next one is going to be that 180. We're back up there. And then we're going to be back down to 0. And then we're going to be back to -1. And then we're going to be back to 0. So now we want to make our new function 1/2 sine of x. Well, this is a y change. It happens like we think. We're simply going to take all our y values and multiply by 1/2. I'm going to make it black so we can see a little better contrast here. Black line for this one. Well, 1/2 of 0 is still 0. 1/2 of 1 would be 1/2. Half of 0 is still 0. Half of -1 would be -1/2. Half of 0 is 0. Half of 1 is 1/2. Half of 0 is 0. Half of -1 is -1/2. Half of 0 is 0. Let's connect the dots here. Drawing our best smooth curve through these points. You can see the black graph is a vertical compression. We have just taken the red graph and squished it down a little bit because we had this factor of 1/2. This is a vertical compression by a factor of 1/2. In our form, y equals a times sine of b parentheses x minus c. This is the way that I'm just showing it the way the book shows this form, plus d. Alright? In this form, a is 1/2. b, the multiplier in here is 1. There's like a 1 multiplier. There is no number added or subtracted inside with the x, so c is 0. In d, there's no number added outside. d is 0. Alright? So those are what we call the parameters. The only change we have is this a multiplier of 1/2. Multiplying by 1 is no change. Subtracting 0, no change. Adding 0, no change. The only change we have is that a. So we could come back up here to the how-to, and we could answer all these things. Determine the amplitude. Well, the amplitude is the absolute value of this. In our case, the amplitude is 1/2. The amplitude is that y multiplier. Determine the period. The period is 2 pi divided by b. Well, our b is 1, so in our particular case, our period is 2 pi divided by 1. That's 2 pi. The period is how long it takes for our business to repeat. Our phase shift is C divided by B. Well, our C is 0, so there's no phase shift. The phase shift is the horizontal change. We didn't change horizontally, so our phase shift is 0. The midline is y equals D. The midline is the line that splits us in half. Here you can see that's the x-axis. That is the line y equals 0. All right, and that's what our D was. So that allows you to answer all the questions that is there. You should be able to do this for any of our functions if you just have what this is. In terms of graphing it, I'm only going to ask you to graph y changes. All right, and that concludes this video.